radical expression. Today we are doing addition and subtracting the radical terms. You have to simplify by combining the radical terms. So like A, if it says 6 root 7 plus 4 root 7, how do you combine them? In case of addition or subtraction, what you're going to do is you're going to take out common. What's common between this term and this term? Eric? Is Eric here? Nope. Carlos?
Yes.
Okay, Carlos, can you tell me what's common between 6 root 7 and 4 root 7?
They both square root by 7.
Yeah, they both have square root of 7. Is there anything common else? Anything else common between them?
They're even numbers.
You can write it like this, right? 6 you can write as 3 times 2, right? And 2 you can write, 4 you can write as 2 times 2, correct?
Correct.
What's common between them now? This term has 3, 2 and root 7. This has 2, 2 and root 7. So what's common between them?
The 2's.
2's and root 7, right?
Yeah.
Okay. I took out 2 and root 7. What I'm left with here?
If you want.
From this term, I took out 2 and root 7. What am I left with?
With 3, 7.
3. Just 3. 2 and root 7 I took out. I'm just left with 3.
So just 3.
Yeah, what about the second term?
2.
Just 2. Okay, let's solve the bracket first. What is 3 plus 2?
5.
5. So you multiply this thing with 5. What is 5 times 2 square root of 7?
5 times 2. 10.
Yeah, 10 square root of
7.
7. That's it. That's how you combine your like terms. Let's do one more example here. So you have 6 fifth root of 4x plus 3 fifth root of 4x, and then you have minus third root of 4x. Carlos was there, not Eric. So Kenya? Okay, Chanthon?
Hello.
Hi, Chanthon. Yeah. So for this thing, let's see what's common. What's common between 6 fifth root of 4x, third fifth root of 4x, and third root of 4x?
4x.
You're saying square this of 4x, right? Fifth root of 4x, this has 6, and fifth root of 4x, this has 3, fifth root of 4x, and this has 3, third root of 4x.
Sorry, one more time.
You see the question here, right? I have one term this, one term this, and one term this.
Mm-hmm.
What's common between all of these?
The 4x.
But see here, that's not true, because see here, it is fifth root of 4x, right?
Oh, okay. So
this is fifth root of 4x. This is third root of 4x. It's not. If it was fifth root of 4x, then fifth root of 4x was common between all of 3.
Oh, right. Okay. So there's nothing common?
Yes.
For all 3?
There's nothing common. So but these two have something common, right?
Yeah.
What's common between these two?
The first 2?
Yes.
The root of 4x.
Okay, fifth root of 4x. Okay. What are you left with?
Oh, 6 plus 3?
Yeah, 6 plus 3. And this remains as it is because this has nothing common between those two. Okay. What do you get? What is 6 plus 3?
9.
So you get 9 fifth root of 4x minus third root of 4x. You cannot combine if their roots, it's not the same. Fifth root and third root is different. You cannot combine them in case of addition and subtraction. In case of multiplication and division you can, but not in case of addition and subtraction.
Got it. So you would just leave the answer like that?
Yes. Try this problem yourself, everyone. 2 square root of 5 minus 7 square root of 5 plus 4 square root of 5. Do this problem. Sorry, let me show you. Joshua Hernandez. Maria.
Yes, I'm still writing it down.
Yeah, sure.
So, can we combine 2, 7, and 4?
Yes. So what's common between them?
The inside is 5, too.
Square root
Right.
of 5, right?
Good morning.
Yeah.
So what are you left with?
2 minus 7 plus 4.
Okay, which is equal to?
-1.
What is square root 5 times -1?
Negative.
Yeah, negative square root of 5. Perfect. Okay, let's do one more example. Okay, you are given 3 square root of 8 minus 5 square root of 2. Niza. Is Niza here? No. Joshua. Joshua Ramirez. Yasmin. Yasmin is also not here. Okay. Can I have Fernando?
Yep, I'm here.
Okay, Fernando. For this case, okay, let's solve this problem here. 3 square root of 8 minus 5 square root of 2. Okay. I need to simplify this further. Okay, square root of 8. What is square root of 8?
Is it 2 times 2 times 2?
Okay, you are saying 2 times 2 times 2 minus 5 square root of 2. Okay. If I have to simplify this, what does it become? How many 2's can I take out outside?
Just one? One.
Yes, 1 I take out. What I'm left with inside?
4. If you multiply 2 and 2.
No. How do you take out 1, 2 is, since it's 2, if it's nothing, it is 2. You make pair of 2, right?
Okay.
From one pair, you take out 1 only outside. Since if it's nothing here, there is 2. If it's nothing there, that means there is 2. So you make a pair of 2. From each pair, you're going to take out only 1, 2 outside. What are you left with? Just 2. Do you get it? How I got this?
Yeah, I see.
And then you get minus 5 root 2. What is this equal to? What is 3 times 2 root 2?
It's 6 and then 2.
6 root 2 minus 5 root 2. And how do you simplify this?
Is it just, do you subtract 6 by 5?
Yes, you
Obviously
take
1.
Yeah,
So 1 square root 2.
yes, exactly. You take out root 2 outside, you get 6 minus 5, which is just root 2 times 1, which is root. If you can do it directly, you can do that way also.
Okay, I see.
Yeah. But that's how you simplify. You have to simplify the square root of 8. 2 you cannot simplify because 2 is a prime number. Let's do one more example here. So you have 9 root 5 minus 4 root 3. 9 root 5 minus 4 root 3. Jesus? Jesus? Not here. Brett? Is Brett here?
I'm here. Yeah, I'm here.
Okay, Brett. So you need to combine this, okay? 9 root 5 minus 4 root 3. How do you simplify this?
I don't think you can.
Exactly, that's true. You cannot, because root 5 you cannot simplify further, root 3 you cannot simplify further, and since they are not the same, there's nothing common between both of these, so cannot be simplified. If you cannot simplify, you cannot simplify. Very good. Right.
For the answer, would we write cannot be simplified or just no solution?
No, cannot be simplified. Solution is itself. Let's do one more example here. So let's see here. So you have cube root of 2 minus 7x cube root of 2 plus 5 cube root of 2. They say combine like terms. Okay, Lauren, is Lauren here? Okay, not. Jordan?
Which Jordan?
Jordan Paulo.
I'm here.
Yeah. So how do you combine this thing here?
Would that be a negative 7 or just 7?
It's negative 7x.
So negatives. So we combine negative 7.
Okay, let's see. How many terms are there, Jordan, here?
3.
3. Is there anything common between all of these 3?
Yeah.
What is it?
The 3 square root 2.
Okay, I took out 3 square root 2. From this, I took out 3 square root 2. What I'm left with?
Negative 7.
No, from here, from first term. You took out 372. What are you left with? Basically, you're
What?
dividing. If you divide this thing by 372, what do you get? 3 square root of 2. I divide this 3 square root 2 by 3 square root of 2. What do you get?
1.
1. Yes. So when you take out, if you're left with nothing, you're left with 1. From this term, you took out 3 square root 2. What are you left with?
Negative 7. Minus 7.
Minus 7, and then x also. Okay. From this, you took out 3 square root of 2. What are you left with?
5.
Plus 5. Can you combine anything?
The 1 and 5.
Which becomes
6.
6 minus 7x.
7x.
And then you can open it, multiply again, it becomes 6 third root of 2 minus 7x third root of 2, and you cannot simplify it further. Let's do one more example here. So you have third root of 2x to the power of 6 y to the power of 4 plus 7 third 2y. Cat?
Yes.
Okay. How can we solve this?
I'm just gonna finish writing it and then I'll
Yeah.
help you.
Sure.
It's a little different from the other ones we've done, so I'm just trying to think of what to do first. I'm not sure.
So whatever is inside, let's simplify this. 2y you cannot simplify it because there is just 1, 2 and 1y. You cannot simplify this cube root. But you can simplify here. So let's see. You have cube root of 2. How many x you have?
2.
6 x. How many of them are there? 6, right?
6.
1, 2, 3, 4, 5, 6. 4 you y you have 4. 1, 2, 3, 4. Plus 7 cube root of 2y. How many pairs will I make? Pair of how many?
3.
3, because there is a cube root, right? 3. So I make pair of 3s. Okay. You tell me what will I take out?
You would take 2 x's, 1 y.
2 x's and 1 y. And what I'm left with inside?
Just 1 y.
And a 2 number also.
Yeah.
So you're left with 2y plus 7, 3, 2y. Okay. What? Anything common between these two?
The 2y.
Okay. Cube root of 2y. What am I left with inside?
X squared y plus 7.
Yes. And you cannot combine these since they are different. They are not like terms. So that's our answer. Once you got this, I want everyone to try these problems. You're gonna try 5th square root of 2 plus 3 square root of 8 plus square root of 18. And next thing you're gonna try is 3 square root of x plus and 5x. Try these two problems. Is Caesar here?
Caesar.
Yeah. Caesar, how can you do this one?
Well, let me tell you.
Yeah. It's okay, it's okay. Do yourself first, and then once you're done, you can tell me.
Oh.
Julian,
Yes.
you'll be giving me to the answer to the second one, the B part.
Okay, I got the first one.
Okay, so how do you do it? How do you do it?
So you gotta try to make them all the same root.
Okay.
I took a 8,
Mm-hmm.
so I made that 2 times 2 times 2,
Okay.
and then you pulled the 2's from that,
How many twos?
2 of them, because you're looking for pairs because it's squared.
Okay. And then what do you get outside?
3 times 2
Okay.
square root of 2.
Okay. Plus.
And then I did the same thing for the 18, which ends up being 3 times 3 times 2. And I took out the 3.
Okay. You're left with.
3 times 1, which is 3.
Okay.
Square root of 2.
Okay. Then
And now that they're all the same, square root of 2, I add, or 3 times 2 is 6 for the middle one.
Okay.
So now I got 5 plus 6 plus 3. I got 14 times square root of 2.
Perfect. Good. Good, Caesar. Julian, did you get the second one?
No, I didn't.
Are you still working? You know how to do it?
I'm just a little confused.
Okay. So let's see here. You have 3 square root of x, right? There is just x inside, so you cannot solve. So this remains as it is. What about this thing? Square root of 25x cubed. Let's make factors. What are the factors of 25?
5 and 5.
X cubed means?
X times x times x.
Okay. Pair of how many terms will I do it? What's the number here?
2.
2. So I'm going to make pairs of 2. I made pairs of 2. So I have 3 square root of x plus how many 5 and how many x will I take out?
1 of each.
1 of each. And what I'm left with inside?
1x.
1x. Okay. So is there anything common between the terms?
Yes, the x.
Square root of x. What am I left with inside?
Inside it's going to be 3 and plus 5x.
Perfect. That's it. That's your answer. Perfect. That's it. You cannot combine them because this does not have x. These are not like terms. Next topic we are going to is product of...
I have a question, Professor.
Yes.
Just for some of them, you write the answer like you did that last one.
This thing is the final answer. That's how you're going to leave.
So it's square root of x times 3 plus 5x in parentheses.
Yes,
Okay,
exactly. If
that's
you cannot
cool.
combine them. Yes.
All right, thank you.
Yeah. Product of 2 or more radical terms. Now you're multiplying. Product means multiplication. So example, it says you have to multiply square root of 3 by x minus square root of 5. You have to multiply these two. For multiplication, since you have to multiply square root 3 with this whole bracket, you're going to multiply this thing with each and every term inside. So it will become x square root of 3 minus square root of 5 times square root of 3. You're going to multiply the square root of 3 and multiply with each and every term inside. You cannot do much about this thing. This remains as it is. But we did in the last lecture that if you had, square root of a and then square root of b, this was actually equal to square root of a times b. You put them inside a common square root in case of multiplication. Now these two are multiplying each other. So they go inside a common square root and becomes 5 times 3. So it becomes x square root of 3 minus square root of 15. First you distribute and then combine if they have the same square root. If they have the same root, you can combine them and make it into one root. Only in case of multiplication and division, not in case of addition and subtraction. Let's do one more example. So they say you have to multiply cube root of y
Professor?
Yeah.
Do you mind just slowing down a bit? Like if you want to write it down and then explain it. It's hard to do both at the same time.
Okay. I'll go slower. Okay, I'll go slower. Yeah. Next question is cube root of y and then cube root of y square plus cube root of 2. It's the same way. Try to do this problem the same way. Julian, oh, he gave me the answer already. Dylan Joseph.
Yes.
Okay, Dylan Joseph. So how are you gonna do this one?
Wouldn't you combine the y squared and 2?
Okay. What does it be? You can combine them?
Oh wait, no, because it's A and B, so it'll be
It's addition, right? Addition you cannot combine.
yeah.
In case of multiplication, you can. So how do you do it? First, you open the bracket. How do I open the bracket, Dylan?
I don't know.
Multiply this thing with each and every term inside. Multiply this outside term with each and every term inside. What do you get?
Wouldn't it be y to the third?
Yeah.
Plus
Third
2.
root of y, and then there was third root of y square. So you multiplied these two. Plus, what do you get?
And then 2y.
Y to y. Or is third root of
Oh wait, no, plus third root 2.
third root of 2, and you're going to multiply this thing also with this thing, third root of y. This is known as distribution. Since it's outside the bracket, it's multiplying. You're going to multiply this with each and every term inside. You're going to multiply with this also. You're going to multiply with this also. Do you get it, Dylan?
Kind of.
Okay, let's see. You're going to, after this, we'll do one more problem together. Okay. Here, let's see. Now these things. Both of them have third root, right? Both of them have third root, right?
Yeah.
And it's multiplication. Now you can combine. What does it become? Third root of
Y to the third.
y to the power of third, which is y to the y square, which becomes y to the power of third. You're correct. Can I combine these two, Dylan?
2 and y, no.
Why not? Do they have the
It's
same
not-
root?
Wait, would it just be 2y?
Yes, 2y. Since they have the same root, I can combine them. If this was
Yeah.
2 and this was 3, I cannot. Since they have the same, I can combine them. So it becomes this thing. Okay. What's a cube root of y cube?
Wouldn't it just be y?
Just y. Correct. And you get cube root of 2y, which you cannot simplify further.
Mm-hmm. Okay.
Yeah. Let's do one more problem here.
I get it.
Perfect. So next is 4 minus root 7 square. 4 minus root 7 square. You have to solve this thing. This whole square. Okay. Rockwell,
Yes.
what does this whole square mean?
4 squared is 16. 4 squared is 16, and then square root of 7 squared.
No. This whole square means, when you write 2 square, what does that mean?
It means 4.
So yeah, you're multiplying 2 times, right?
Yep.
So you get 4. What is 2 cube?
2 cubed is 8.
So you're multiplying 2 3 times, right? So when you have this square, this basically means you're multiplying this whole thing twice. That's what it means.
So like a, so kind of like a, what would you call it?
Yes.
Like polynomials kind of thing.
Yes,
You just
exactly.
separate them. Like
Yes.
you distribute and then you multiply.
Exactly, yes. So once you got this thing, since it's square, that means you're multiplying this twice. You're multiplying this twice. Now you're going to use FOIL method. FOIL method on this thing. What does FOIL method says is, F means first terms. Multiply the first terms. 4 times 4, which is 16. What does O mean? You know O, Rockwell?
O.
O means outer ones.
Outer ones. Okay, outer.
First, outer, inner, last. So if you want to write first, outer, inner,
And then enter.
last. So outer
Last.
ones, which is 4 and negative square root of 7. When you multiply, what do you get?
When you multiply square root of 7, or is that negative square root of 7?
Yes, negative 4 square root of 7. You're going to multiply these two, the outer ones.
The outer ones. Okay, yeah, 4.
And what do you, when you multiply the inner ones, what do you get?
that's square root of 49. We just said.
Yeah, it's the same thing. Negative 4 square root of 7, because it's negative square root of 7 and then 4. When you multiply, you get negative 4 square root of 7. And the
Yeah,
last
okay.
ones.
I guess you're not. Okay.
Yeah. And the last
It's
ones
just,
you
it's a lot bigger down there. Looks a lot more spread out down there.
Yeah. You get square root of 7 times square root of 7. 16 remains as it is. Negative 4 square root of 7 remains as it is. This negative 4 square root remains as it is. These multiplication and they have the same root. I can combine them. They become 7 times 7. Okay. 16 minus 4 root 7 minus 4 root 7. This becomes, I make a pair of 2 since it's square root. And from one pair I can take out one outside. I get 7. Combine the like terms. 16 and 7. 16 and 7 gives me
23.
20. 3? 6, yes. Yes, 20.
Did I cut out?
Yes, and then I combine these two. And then what about these two? What is negative 4 root 7, negative 4 root 7?
Oh, wait, no, that's 8.
This is?
8 square root of, is that 8 square root of 7?
Yes, negative 8 square root of 7. Correct.
Yeah, negative 8, got it.
Yeah, perfect. Anyone has any problem? This is a separate, different kind of problem. You have to use FOIL. Anyone who doesn't know how to use FOIL?
Professor, I have a quick question. So when you're using FOIL or you're multiplying 4 by the radical 7, does that become like the root of the radical, or is that just like, does 4 become
it's 4 times.
Root 4 and then 7, or is it just a coefficient?
It's a coefficient. It's a 4 times.
Okay.
Radical still remains the same.
Okay, thank you.
Yeah.
Question as well.
Mm-hmm.
In the beginning of the problem, I just I did it like 4 squared minus 7 or squared minus squared 7, or I don't know how to say
it, but square root of 7 square.
Yeah, and then I just got 4 minus 16 minus 7. How would I know when to use the FOIL method and when to use that method that I had to use?
Okay, that thing which you did is, so let me add. That's a very good question too. Very common mistake. Okay, this is very common mistake everyone does. So when you have a times b to the power of n, and when you have a over b to the power of n, multiplication and division, you can just distribute the exponent. It becomes a to the power of n, b to the power of n, a to the power of n, b to the power of n. You just distribute. Okay, but whenever you have addition, they are adding or they are subtracting, you have to use FOIL method. In case of multiplication division, you can distribute. It's easy to distribute. But in case of addition and subtraction, you have to use the FOIL method. Good question, Kat. It's a very, very common mistake. I want everyone to do this by themselves. Try solving 7 plus root x square. Try this. 7 plus root x square. Rado?
Yeah.
I'm gonna solve this one.
Give me a second. Okay, so do you want me to do it on my own first, or you just want me to walk you through it?
Walk me through it.
Okay, so you're gonna do the same thing. Get rid of that square
So what does it
and
become?
break it up. Is what's that?
What does it become?
7 plus square root of x, and then again you're gonna write that again.
Okay, I wrote that again. Okay.
And then you're gonna do the FOIL method, but I kind of just distribute it.
Okay. What do you get when you distribute?
So it's gonna do 7 times 7, which is 49.
Okay.
And you're gonna do 7 times square root of x, which is 7 square root x, or 7 square root x.
Correct.
And then you're gonna do square root x times 7, which is the same thing, 7 square root x.
Okay.
And you're gonna do square root x times square root x, which equals
I write it like this.
like that.
This is 49. Okay. Can you combine these two?
Yeah, so 49 plus 7 is 56.
No, you cannot
Oh wait, I'm tripping. Yeah, my bad. Sorry. How did we do it last time?
Let's keep this as it is right now. Okay. Here, can I combine these two?
The square root x's? Yeah, so it's just going to be, isn't it x squared? So it ends up being just x.
Yes, exactly. It's going to be just x. Okay. Can you combine anything else, Gerardo? See, this is a constant, right? There is no other constant. Constant is just a number. There is no other number. And there is just x. There is no term with just x. These both have square root of x. So that means you can combine these two. What does it become?
So you combine the 7 square root x with x?
7 square root of x. Since these both have square root of x, right? They both have the same square root. You can
Okay, so it's going to be, aren't you just adding it? So it's going to be 14 square root x?
Exactly, yes.
Okay.
Plus x. And you cannot combine them because this is constant. This has a square root of x and this is just x.
Okay.
Good. Any questions, anyone so far?
Could we do a couple more of these?
Yeah. We're gonna do more. Let's see. You have 4 square root of 3 plus square root of 2, and then you're gonna use square root of 3 minus 5 square root of 2. You're gonna do these two, multiply these two. Jose?
Yeah.
Okay. Can you tell me how you're gonna do this?
Would you multiply the 4 square root of 3 with the square root of 3 and then with the negative 5 square root of 2?
Yes. So first you multiply with this. What's my next step? Yes, use FOIL method.
Wouldn't that just be? Oh, would you? So then I multiply the 4 and the square root of 3 with the negative 5 and square root of 2.
Exactly. Negative 5 square root of 2. Then?
And then you do this square root of 2 times the square root of 3.
Perfect. Okay. What's the next one?
And then you do the square root of 2 times the negative square root of 5. Negative 5 square root of 2.
Okay, perfect. Okay. What is 4 square root of 3 times square root of 3?
Wouldn't you just combine the 3's?
Yes.
So it would just, and then would you take them out?
Yeah, because it's square root, you make a pair of 2.
And then you take them out, right?
Exactly. How many did you take out? 1 or 2?
You take out one pair and then you do 3 times 4, which is 12.
Exactly. Okay, this is what you got for the first term. What about the second term? What does it become?
second term. Would you just leave it as it is?
No.
Or would you combine it and you'd get...
Yes.
Do you get 9?
No, 4 times minus 5. It's multiplication.
Oh, so 4 times negative 5?
Yeah.
So that'd be negative 20?
Negative 20, and inside the square root, what will I have?
Do you combine the 3 and 2 together?
Yes, since it's multiplication, you can combine.
Okay.
So what do you get?
So you get 3 times 2, which is 6.
Okay. And you cannot solve it further, right? Because you don't know what is the square root of 6.
Yeah.
What about this thing? What does this become?
2 square root of 2 times square root of 3. Wouldn't that also be square root of 6?
Exactly. Since it's multiplication, I can combine. Okay. What about this one?
Negative 5 square root of... Oh, wait. Wouldn't you just combine the 2's and then take them out again?
Yes.
So then you'd get negative 10.
Yeah, you get negative 10. So you get negative 2 square root of... And there was square root of 6. Square root of 6 plus square root of 6 negative 10. Anything else you can combine?
You could combine the negative 20 and just the square root of 6.
So what do you get?
Would that just be negative 19 square root of 6?
Exactly. What else you can combine?
You can combine the 12 and the negative 10.
What do you get?
And then you just get 2.
Positive 2. Perfect. Really good. You did yourself really good, Jose. Oh, sorry.
Thank you.
Any questions, anyone with this?
Where did you get the negative 19?
Okay, so 20, so he had negative, so he's combining these two. Negative 20 square root of 6 plus square root of 6. So you had negative 20 square root of 6 plus square root of 6, right? What's common between them is square root of 6. What are you left with? Negative 20 plus 1. If you're left with nothing here, it is 1. That's how we got negative 19 square root of 6. Did you get it, guys?
Okay, just a quick question. When would you do, like, I thought if you had those two, like two square roots of a number, you would just do the square root times each other, like 6 times 6. You know what I mean?
So, you know the difference between is, so, note, when you have something like, okay, in multiplication, if you have something like this, you just multiply and put in a same bracket, okay? In case of division also, you put it in the same bracket. That's not a problem. If I say division of a square root divided by b, since they have the same square root, I can combine them and I can write it as this thing, okay? But in case of addition, if you have something like a square root of b plus c square root of b, you have something like this. In case of addition or subtraction both, this you cannot combine. What you have to do is, you have to take out common and see what you're left with inside. Okay? So, let's do one more problem before we go further. Okay. You have square root of a plus square root of b. Then you have square root of a minus square root of b. Brian. Is Brian here?
Yeah, I'm here. I'm writing it down.
Yeah.
B times square root of a minus square root of b. So it's FOIL method.
Mm-hmm.
So the first term is going to be square root of a times square root of a, which gives you a. Second term is going to be square root of a times negative square root of b. So that's going to be minus square root ab. Inner term is going to be b times negative square root of b, which is going to be negative b. So you're going to have the negative square root ab and the positive square root ab are going to cancel each other out, so you're left with a minus b.
Perfect. Good. Solving, simplifying by addition and subtraction. Okay. Next topic I'm moving to is rationalizing. Rationalizing the denominator. Rationalizing the denominator. Suppose you have something like, I say, 4 over 7 plus root 3. You have 7 plus 4 over root 3. Now you have here is, okay, you have here two terms, 7 plus root 3. Whenever you have something like this and I say rationalize the denominator, that means you cannot have any term with a square root in the denominator. You cannot have square root in the denominator or any root in the denominator. So but that's what it means, you cannot have any root in the denominator. In this case, what you're gonna do is, so if you just had root 3, if you had just 4 over root 3, you will multiply by root 3, divide by root 3 and solve. But in this case, you have 7 plus root 3. What you're gonna do is, you're gonna multiply and divide with the same term, but you're gonna multiply and divide. Since it's 7 plus root 3, you're gonna take 7 minus root 3. You're gonna change the sign of one term. I change the sign of root 3. It's up to you which sign you can change the sign of 7 and keep the sign of this thing the same. It's up to you. But change the sign of one term and keep the other term same as it is. So I'm keeping 7 as it is, but the sign of root 3 I'm changing to negative. You're gonna multiply and divide with that thing. When you multiply, you're gonna multiply 4 with each and every term here. 4 times 7 becomes 28. 4 times negative root 3 becomes negative 4 root 3. And in the denominator, multiply, FOIL method. First by first, you get 7 times 7. First, outer ones, last one, outer ones becomes 7 times negative root 3. Then you have inner ones, root 3 times 7, and then outer ones. You get negative root 3 times root 3. So you get 28 minus 4 root 3 over 7 times 7 is 49. This becomes negative 7 root 3 plus 7 root 3, and this thing is basically 3. They cancel. You're left with 28 minus 4 root 3 over 49 minus 3, which is 46. Any problem so far? How I did this. So when you're rationalizing the denominator, when there are two terms, when it's one term, you just multiply and divide with that term. If it was just root 3, you multiply by root 3, divide by root 3. That's it, and then solve. But when there are two terms, you change the sign of one term. I change the sign of root 3, multiply and divide with that root 3 and then solve. But now after this what you're going to do is, you're going to make factors of this thing. 28, let's make factors. I can divide it by 2, it becomes 14, 2 and 7. So it is 2, 2 and 7. 4 I know is 2, 2 and root 3. Let's see, 46. 2, you get 23. What's common between these two? Common between these two is 2. There's 2 2's. What are you left with is 7 minus root 3 over 2 times 23. Now see, What can you cancel from the numerator? What can you cancel from the denominator? Since they're multiplying, these two are multiplying and these two are dividing, you can cancel each other. 2 and 2 gets cancelled. You're left with 2, 7 minus root 3 over 23. And then you open the bracket here. 2 times 7 gives me 14 minus 2 root 3 over 23. So you have to make factors, take out common and then cancel. Note, you cannot just cancel. Oh, 4, I see 4 here, I 4 here, cancel. No, that's not how you do it. You have to take out common and then cancel, then simplify.
Professor, can you just re-explain real quick from 2 times 2 times 7 minus 2 times 2 square root 3, just what you did with those twos? Did you just subtract them, or?
No, did you understand how I got these? How am I writing this?
I got how you got the factors, but
Okay.
then the
After
the
this,
part
what I did
after
is-
it where you got 2 times 2 parentheses 7 minus the square root 3.
Okay.
Like, I get where those numbers are coming from. I just don't know what happened to the other twos.
Okay, so let's see here, right? Okay, let's see here. Now let's see the numerator only. What's common between both of them?
Between the numerator or the numerator and the
Numerators,
denominator?
just the numerator, just the numerator.
It's the 2 twos.
So I took out 2 2s outside.
Okay. Oh, okay.
And then what I'm left with inside is 7 minus root 3.
Got it.
And you reach this point.
And then, yeah, okay, that makes sense. I just kind of like missed it when you were
Yeah.
explaining it.
And then you cancel whatever you're left with, you cancel and then you solve. Do you understand after
Yeah.
that what we did?
Yeah, that makes sense.
Okay.
It was just that one part I kind of just like didn't really get it. So thank you.
No, yeah, no problem. Any questions, anyone so
Professor-
far? Yeah.
Yeah, I have a question just for like if we're taking a quiz or exam on my math lab for this. Is I don't know, the way I look at that is the answer can be really expressed 2 different ways. 2 times 7 minus root 3 or 14 minus 2 times root 3. Which does my math lab want?
It's
Right?
this
Because
one.
like when
It's
you're
this
doing the
one.
homework, it's fine because they'll say, "Oh, you just didn't simplify enough," or "We want to express this way," and you can correct it. And it's fine. But when you're taking a test,
Yeah.
they're just going to mark you as wrong.
It's this one.
Okay.
You have to simplify it the most you can. Yeah. Try this problem by yourself too. It's like, if you know this, try yourself first. I'm gonna do it here. I want you to try it yourself. 4 plus square root of 2 over 5 minus square root of 2, 5 minus square root of 2. Try this problem yourself.
Real quick, Professor, what was the answer to the last one?
14 minus
14 minus
2 root 3 divided by 23.
Oh, okay. Okay. All right. Got it.
Daniela?
Yeah.
Okay. I need to rationalize this. Rationalize the denominator. How do you do it?
I have no idea.
Did you understand the previous problem?
No,
Why didn't you ask me then?
because I don't feel like it.
You have to. The thing is, that's not how you're gonna pass the class. You need to ask me. If students are asking, you don't even stay after the class, Daniela. You need to stay back and ask me. It's like, hey, how to solve this? I don't understand the concept.
Mm-hmm.
Okay. So what you're gonna do is, here, you're gonna help me do, you know how to use FOIL method or no? You did not even understand
Yes,
that? Yeah, okay.
I do.
Okay. What you're gonna do is, how do you rationalize is, in the denominator you have square root of 5 minus square root of 2. Okay. Change the sign of one term and keep the other term as it is. Which term you want to change the sign? Do you want to change the sign of root 5 or root 2?
5.
5. Okay, it was positive. I make this as negative and the other one remains negative. It's up to you which one you want to do. You said you want to change the sign of root 5. I change the sign of root 5. Root 2 will remain as it is. I'm going to multiply and divide with the same thing. Okay. In the numerator, use the FOIL method and tell me what do you get. Multiply the first terms. What do you get? What are the first terms, Daniela?
So you multiply 4 to the negative 5.
Square root of 5. What do you get? What is 4 times negative square root of 5?
It's going to be negative 4 square root of 5.
Perfect. What are the outer ones?
And then the other one isn't it going to be... We'll multiply 4 as well.
Yes.
Again, like 4 with negative square root of 2.
What do you get?
Negative 4
Negative 4 what?
is square root of 2.
Okay. What's the next term? What are the inner ones?
And then it's the square root of 2 times negative square root of 5.
Okay. What are the last ones?
And then the other one is square root of 2 times negative square root of 2.
Okay, perfect. What about the denominator?
It's square root of 5 times negative square root of 5, and then negative, then square root of 5 times negative square root of 2, and then negative square root of 2 times negative square root of 5, and negative 2 times negative square root of 2.
Okay. Okay, in the numerator you get negative 4 square root of 5, negative 4 square root of 2. What is square root of 2 times negative square root of 5? What does this become, Daniela? Square root of 2 times negative square root of 5. Multiply these two terms and tell me what you get. Negative 2 times negative square root of 5.
Negative 10. Negative 10.
Square root of
10.
Okay. What about the next one? What does it become?
Negative square root of 4.
Which is?
4.
Square root of 4 is?
Square root of 4.
Okay. Let's write that. Okay. What does this become? Negative square root of 5, square root of 5.
25. Negative square root of 25.
Okay. Then negative square root of
10.
Then next term, what do you get?
10. Negative square root of 10.
It's positive. Negative makes it positive.
Okay. Oh, I didn't see that.
Okay.
So positive 10.
What about the last one?
Positive 4.
Square root
of 4.
Okay, so let's write here. I don't know what is square root of 5, so I write it as it is. I don't know what is square root of 2, I write as it is. Square root of 10, 5 and 2 factors I cannot simplify, so I write as it is. What about square root of 4? Do you know what is the square root of 4?
2.
Okay, I write here 2. Okay, what about here? Can you tell me what square root of negative square root of 25? It's 5, negative 5. Square root of 10, what is negative square root of 10 plus square root of 10?
10.
They cancel, right? One is positive, one is negative, they are the same, they cancel.
Yes.
What's the square root of 4 plus square root of 4?
2.
Plus 2. What is negative 5 plus 2?
3. Negative 3.
Negative 3. You cannot simplify further. That's your answer. Good, Daniela. Any questions, anyone?
I had a question about, so we're allowed to multiply the radicals, like inside for this method?
Yes, if they're multiplying each other, yes, you can combine them.
Okay.
If they're
So,
not.
like, for example, I know in the past, like, if there was, for example, like negative 4 radical of 5, we weren't able to just multiply that to, like, another radical of
Like
itself.
this?
But now we are.
Like this?
Yeah, or no, like, how did we combine?
See
Or
here.
like radical 5 to radical 5. We never multiplied that before, so now we're doing that in this method.
No, we did that. In the last lecture, actually, I taught you this thing only. When you have
Yeah.
something like this, in case of multiplication, you can combine and it will become square root of 25, which is 5.
Okay. No, I remember that from last lecture. I was just wondering because this is a different method, so it's still along the same lines.
It's the only difference is if you have something like I say square root of 4 plus square root of 5, you cannot do anything about it. You're done because they're not the same. You cannot do anything about it. But if you have square root of 4 times square root of 5, then you can combine. It becomes 4 times 5.
Okay. Yeah.
I have a question.
Yeah.
That makes sense. Thank you.
So I chose to multiply by square 5 plus square 2.
And then your answer would be this thing. Everything would be positive, right?
Yeah, so would that be correct?
Yes, it's absolutely correct. It will accept both answers. That's correct.
Okay.
Yes.
That's what I was trying to get.
Yes.
And to add on to that, technically it's just a bunch of negatives on the numerator and denominator make a positive, right?
Yes, basically what they are doing is multiplying the whole numerator also with negative 1, denominator also with negative 1.
Okay.
Yeah. I mean, technically it's the same answer.
Got it.
I have a dumb question.
So, no problem. No problem. Yeah, Christian.
So with the square root of 10, since it was initially the square root of 2 and the square root of 5, could you break that down again? And would that change the negative 4 square root 5 and negative 4 square root 2? That makes sense.
I mean, you can do that, but then again, you'll be again simplifying further. So what you're saying is, you're correct. You're not wrong. You're thinking it correct. You're like, oh, I can combine that. It is basically square root of 5, square root of 2, and then 2, right? You're saying, I want to combine these two. I take out square root of 5 and I'm left with 4 plus square root of 2.
Yeah.
You're saying like this, right? And then left with 4 square root of 2 plus 2. But then again, you have to multiply. Again, you will reach the same point. You have to open the bracket, right?
Yeah.
Yeah.
Okay, thank you.
Yeah. Okay. So next thing we're going to move to, so this was about rationalizing. Next thing we're going to do is, it's known as terms with differing indices. What does it mean is like example I will take, it says x plus y to the power of 3, and then you are taking 4th root of this thing divided by square root of x plus y.
Professor, what's that last word?
Indices. 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 Indices means the term is the same. X plus y, the term is the same. Only the power is changing. Different indices, different powers. Okay. Joshua, Jess? Not here. Okay, Sabrina?
Here, sorry.
Hi.
Just
Yeah,
turning on my
Sabrina.
camera.
Yeah. So Sabrina, I have here x plus y to the power of 3, right? How can I write 4th root as? Is there a different way I can write 4th root as to a power?
Yeah.
Which is? How can you write 4th power as? 4th root as? In the form of power.
Oh wait, no, I don't know.
It is 1 over 4. That's how you write it in the form of power.
Oh, okay, yeah, 1 over 4.
It means the same thing. In the denominator, how will I write x plus y to the power of what?
X plus y to the power of
Now,
1 over 2.
We did this before. We did a property of exponential which said if you had a to the power of m to the power of n, this is actually equal to, we did this property before, guys, a to the power of m times n. You just multiply the exponents.
Yes.
So what does it become? X plus y to the power of what? What is 3 times 1 over 4?
X plus y.
What is 3 times 1 over 4?
Would you add a 1 under the 3? So it would be 3 over 1 times 1 over 4?
Which is?
3 over 4?
Yes, 3 over 4. So it becomes x plus y to the power of 3 over 4 over x plus y to the power of 1/2.
1 over 2.
Divisions. Also, we did one more property, Sabrina. Division, same base, different exponents. What do?
You subtract them?
Exactly. Your base will still remain the same, but you subtract the exponents in case of division. Correct. Really good. What is 3 over 4 minus 1 over 4? 1 over 2.
Do we make the denominators common?
Yes. So you're going to multiply by 2.
So it would be 3 over 4 minus 1 over... No. Minus 2 over 4.
Which becomes?
1 over 2.
1 over 4. 4.
1 over 4.
Yeah. And if I have to
so the
write
denominator is the same.
If I have to write it back in radical form, how do I write it?
In radical form, it would be x plus y with 4.
Yeah, 4th root here. So 4th root. Perfect, Sabrina.
Professor?
Hello, yeah.
Can you explain what indices, is that how you say it? What are they?
Indices basically means powers. So see, they have the terms, the base is the same. Basically what it means is same base, different powers. See, my basis is the same, x plus y, but my x powers are different.
Okay. Thank you.
Yeah. Okay. Let's do one more example here. You have square root of x cube and then cube root of x. And you're multiplying them. Square root of x cube and cube root of x. It says multiply and simplify. Jordan,
Yes.
you have to multiply and simplify this.
Okay.
Okay.
So
Yeah.
we start by so the radical x to the third power would be what do you take an x out and then you leave one x in there? Or are we doing this method now?
You can do that also. You're correct. You're not wrong. You're absolutely correct. So what you are saying is, that's correct. Whichever way you want. Correct? Let's do that way. You're saying you take out x. What are you left with?
Yeah, so you're just left with an x, radical sign x.
Okay.
This
And
is
then
one pair.
this thing is cube root of x, right?
Yes.
You're still not done. All of them are x. Let's see if you can combine. How can you write this as x to the power of?
X to the power of, well, that one's still to the third, but that one is that one to the second because it doesn't have a number right now?
Yes, yes.
Okay.
So how do you write in the power form?
You're going to write x and then 2 and the radical sign and then x inside.
But in the form of power, it becomes 1 over 2.
Oh, okay. Yeah. So it's going to be 1/2.
What about this one?
And then, yeah, 1 over 2.
And in this case, what will it be?
And then for this one, it's going to be x and then 1 over 3.
Perfect. Yes.
1 over 3.
Yes. Multiplication now, Jordan. They're multiplying x, x, x. Note my base is the same, x.
Mm-hmm.
When bases are same and you're multiplying, what do you do?
I think you just keep it as is.
So you add
if they're all the same.
See, in case of division, my base was same, right? X plus y. Only my powers was different, so you subtract it.
Okay. So then it would only leave you with 1x, and then you subtract the fractions.
No, see here, it's the previous topics we did 10.2. So if you have a over m and a over n, my bases are the same and you're dividing, then you subtract. But if you have a over m and a over n and you're multiplying, in this case you're gonna add.
Okay. I think I'm just a little confused because all the problems seem to be slightly different. So they're kind of the same, but they're also different. Like one might have 2 variables while the other one just has 1, and then it's just they're all a little different. So I get confused, but that makes sense.
So what does it become? What I'm gonna add?
Okay.
Can you tell me?
So we're gonna add the 1/2 and the 1/3.
And what's the power of this x? There is one more x.
We're just gonna have 1x then, aren't we?
Yes.
Or are we gonna do
So it will be 1 plus 1/2 plus 1/3.
1/3.
See what you get. Solve. 1 plus 1/2 plus 1/3. How do you make common denominator?
You start by multiplying.
With what?
So we could start with the 1 over 2. I'm gonna do multiply the top and bottom by 3.
Okay.
And then you're gonna get 3 over 6.
Okay, 3 over 6.
And then you're gonna go to 1/3 and you're gonna multiply each side by 2.
Oh, you got
and that's gonna and then you're gonna get 2 over 6.
Okay.
And then I guess with that 1 over 1, we could just multiply each side by 6. So it's just gonna be 6 over 6.
Okay.
And then you add them all and you get 11 over 6.
Okay. And how do you write as a final answer?
Is it gonna be equals x 11 over 6?
So 6th root will become here, right? 6 will become here. Denominator becomes a root and everything else remains inside.
Okay, so 11 will be the power x to the 11th power and then 6 on that side.
Note,
Okay.
Jordan, can you simplify this further?
No.
Yes, we can. How many 11s are there? 11 x 7. 6, 7.
You repeat that? Oh, there's 11 x's.
Yes, there are 11 x's.
Okay.
I will make pair of how many?
Let me just write it out for a second.
Yeah.
Oh, we're only going to be able to do one pair, and then there's going to be 5 left over.
Exactly. Okay, so it becomes 6th root of x to the power of 5.
X, yeah.
Perfect. That's your final answer.
Okay.
Good. Any questions, anyone? With this? Yeah.
Quick question. Just to be clear, if those were, so say that was 3 or cube root x times cube root x, that would be cube root x squared, right?
Yes.
I have to do all this?
Yes.
Okay, just making sure.
Okay. Let's.
I'm gonna go to the bathroom real quick.
Sure, no problem. Yeah. Let's see what's the. I'll give you like 5 minutes, 10 minutes break. We'll meet at 11. Let's meet at 11.
Loud, bro.
Professor,
Yeah.
my internet cut out. Could I see the last problem we just finished?
Yes, Kat. Here. Were you on this problem?
Yeah.
Okay. See if you understand it, okay? If you do not, ask me, I'll explain.
Okay. I just have one question.
Yeah, okay.
So I got, I understand that x, the square root x, or square root 6, x, 5. I understand that, but how did we get 3x squared?
This is a separate problem, okay?
Okay.
This is a separate problem. Someone asked me a question.
Okay. I'll just